of multiple pieces of graphs, right? So when we look at that first graph, this graph is composed of 3 segments. Why would they be segments? Think about your geometry terminology here. Why are those segments? There are 2 endpoints on either side. So when we have piecewise functions, you're either going to have segments that look like this, or you're going to have rays, where we have endpoint on one side and an arrow on the other. And we'll do both today. So let's start by just talking about domain. What is the domain of this left segment over here? I'm going to write it in interval notation just because that's my default. You can do inequalities if you want, but what's the domain for the left segment? Where do you start? -6. Now, -6 has a closed dot, so what symbol would you put with the -6? A bracket. And that goes until what x value? -3. Now, that -3 has an open dot, so you put a parenthesis. I'm going to skip the range part for now. We'll just deal with domain for now. We'll talk about range later. All right, what is the domain for the second segment here in the middle? -3 with a closed dot, so -3 with a square bracket until when? 4 with an open bracket, or a parenthesis. And what's the domain of that last segment? 4 to 8. All right, 4 has a square bracket, 8 has a parenthesis. Now, if I had to write, I have 3 different domains there. If I had to write the domain for the entire graph, what would you say it would be? -6. And here's the tricky part. When I get to up here, when I get to -3, see how there's an open dot? Do I have to stop my domain, or does it keep going? Do the x's keep going? It keeps going. Why? Why is there a value here? Why do I not skip -3? What do you think, Rachel? Because there's a closed dot underneath. So there's still a value on your graph at -3. So you start at -6, it just keeps going, going, going. Same thing at 4. I have a closed dot up here, so my domain keeps going until you get to 8. So even though each piece has its own domain, we have one big domain of the graph. Okay? All right, let's look at the next graph here. We'll ignore the range for now. This graph is composed of segments or rays. Okay? 2 rays, right? 2 rays. How many equations do you think it would take to write? Like, how many equations do you think it takes to make that graph? 2. Why do you think it takes 2 equations? Because there are 2 rays. Good. So each piece gets its own equation. What is the domain for the left ray here? What's the domain? So -infinity until 3. Okay, now I'm going to ask you to write that also as an inequality this time. Okay, so if I wrote that as an inequality, because a lot of our domain within piecewise functions are going to be written with x's as inequalities. You would say all the x's, are they less than 3, bigger than 3, less or equal to? How do I write that as an inequality? X is what? Less than 3. All right? So there I just had you write it twice in 2 different ways. So you can write your domain as an inequality or as an interval. What is the domain for this second part? Start at 3. 3 has a closed bracket, and that domain goes until infinity. How would I write that with an x as an inequality? All the x's are greater than or equal to 3 because there's a closed dot, and everything is to the left. Now this time, let's state the domain and the range this time of the entire graph. So same kind of thing that we did in number 1. When I look on the left here, my graph is going to -infinity. So at least I know my domain starts at -infinity. Now I follow the x's, come from here, come, all the way to 3. There are 2 dots here. Does my graph have a value at 3? Yeah, it has a value up here, so then my domain keeps going until tossed on my desk somewhere, Lauren. All right, infinity. So your domain for this graph is from negative infinity to infinity, even though there are two pieces of the graph. But what about the range? Where's the lowest y value? 1. 1 gets a parenthesis. And then what happens with my range? This one goes, from this dot, it goes up forever, right? Then I have a gap here. But even though there's a gap, if I covered up the top equation, are there still y values happening in the gap here? Yeah, there is. So then this one goes up forever, too. So what do you think should be my range? From 1 to infinity. Yeah, there's no break this time. So I go from 1 to infinity. All those y values get an output. Okay. All right. Instead of just looking at them, let's graph them. So flip your paper over. I don't think you'll need a calculator. If you do, you need to work on your mental math a little bit. This is what the equation of piecewise functions look like. We saw them a little bit yesterday on your activity. So we're going to start with the graph of f of x. And I just want to talk about this for a second. F of x, in case you forgot, means y equals. Okay? So that's the same thing as y equals. Now the way we write piecewise functions is, instead of writing y equals 2x and y equals 5, they put them in this curly bracket so they only have to write y equals one time. It's like a concise, lazy way of writing it. Okay? So these are all y equals equations. So this is the equation part. And then the stuff with the inequalities over here, that's the domain. Okay? Each line, we are only looking at a piece of it. That's why it's called a piecewise graph. So this domain tells us what piece of the graph are we going to be looking at. Okay? So let's graph this piecewise function. So we're going to use the table. I put already x values in for you so we can graph each one. Now these first 5 points we're going to use for the first equation, y equals 2x. So if I put negative 5 into the equation of 2x, what would I get as an output? If I put negative 5 into that function,
Negative 10.
negative 10. Thank you, Jamie. If I put negative 3 in, what do I get? Negative 6. If I put 0?
0.
Okay, 1.
2.
And 2.
4.
4. There you go. All right. Now, before we graph this, we have to think about the dots, the endpoints. So if I look at the domain up here, that tells me what kind of dots. Because sometimes I have closed dots, sometimes I have open dots. Is negative 5 going to have an open or a closed dot? Closed, because it says less than or equal to. So if you want, put a little reminder to yourself next to that point on your table. At x equals 2, should that have an open or a closed dot? Open. So I'm going to put an open dot there. Well, let's plot those points. Let's make sure, though, that when I plot negative 5, negative 10, I put a nice closed dot. Negative 3, negative 6 gets a point. 0, 0, 1, 2, and 2, 4, make sure you have an open dot. Then you can connect them. And I didn't offer you rulers. Is anyone really particular and want a ruler?
Does it matter?
No,
Alright.
I don't care if you're not perfectly sure. Alright, so that's the first piece of your piecewise graph. Now let's use these other 4 points to graph the second equation, y equals 5. Okay. So if I put x equals 2 into that function, what has to be the output? 5. Okay, what about 3? 5. 4 is also 5. 6 is also 5 because y equals 5. It doesn't matter what the input is. Well, at x equals 2, what kind of dot are you going to put on your graph? Closed dot. What about at 6? Also closed because it's less than or equal to. So this one I want you to graph and make sure that those endpoints have nice closed dots. 2, 5, 3, 5, 4, 5, 6, 5. And I connect them to get a second graph. Well, that's your piecewise function. Right? There's 2 pieces. One all points. Any questions so far? Now, when I look at that, let's answer a couple questions. Let's try to figure out what's happening. We'll make it a little bit harder as we go on here today. How many pieces does your graph have? 2. Why are there 2 pieces? There are 2 equations. I know, remember I said this starts off like it seems real easy, but pay attention to all this. This is important. Are these pieces rays or segments? They're segments. Why are they segments? Yeah, there's no arrows. There are 2 endpoints on each segment, right? The picture is up here. There's 2 endpoints on either end of the line. Now, are the dots always solid, always open, or sometimes some of each? Some of each, all right? It depends on the inequality symbol. Sometimes you're going to have a solid dot, sometimes an open dot, sometimes an arrow. You have to follow what the domain tells you to do. Okay. All right, well, what if I ask you this? Were all of the x values that I put in this table for you, were they all absolutely necessary to plot? No, they weren't. Could I have gotten away with fewer points on that table? Yes, I could have. All right, so what does it say? Were all these points necessary? No, you could have used fewer points. Which points, if I were going to use fewer than the 9 that I plotted, which ones do you think were the critical x values? Which ones do I have to put? The endpoints. You have to put the x value of the endpoints. Now, where do you find the x value of those endpoints? Up here in the domain. These numbers, the -5 and the 2, those are the x's of your endpoints. So you need to look at the x value in the domain for each graph. Right? Those inequalities are going to tell us what points we need to plot. Do you think that there are any places, which there probably are because I'm asking you this question, that you might need to do more than just the endpoints? Are there any times where just 2 points aren't going to be enough? Yeah, when it's a curved graph, like x squared. So yes, for example, when you have to graph y equals x squared, or any other parabola, or a curve, an exponential. So think about this. This is really important, so listen to this. When you graph a line, how many points do you need? 2. So if you need 2 points in general to graph a line, a straight line, how many points do you need at a minimum to graph a curve? 3. So most of the time in this case, we're going to use y equals x squared or another quadratic. So you need 3 or more points, but a minimum of 3 to graph a parabola. So sometimes the endpoints aren't going to be enough. You might have to add in a point or 2 so you can see the whole graph. Okay. All right, let's do the domain and range. I'm going to write it up here next to the picture. But let's talk about the domain here. Again, my default is interval notation, but you can do inequalities if you wanted. What's the farthest to the left x value of this graph? -5. Okay, so I have a square bracket at -5. And I go up here, all these x's are covered, I get to 2. But even though I have an open dot, there's a closed dot up above, so my domain keeps going until 6. So I can close bracket. The domain is pretty easy this time, but the range looks a little different. Let's start at the bottom. Where's my lowest y value? -10. All right, that's easy. -10, and then I go all the way up to 4. Now here's my question. Are there any y values in between 4 and 5? No. So here's what you have to do. You have to say, okay, my range goes up to 4. Does it include 4? No. Put a parenthesis. There's an open dot. But I'm not done. I still have y values on my graph. There's just none of them in between 4 and 5. So my range picks up again. Do you remember what symbol you have to do to combine intervals? We didn't really do it yet this year in our class. We've done it. No? It's the U for union. Remember union? Yeah? So U, that means or in math. the math world, but joining and union with, well, where's the next y value? 5. Do I have any other y value other than 5? No, so here's not hard, the new part for you. When I do interval notation, we've never really written an interval for just one number before. So here's how you do it. You do curly brackets around the 5. That's saying just 5. Now, if you forget to put the curly brackets around the 5 here, that's okay. Because I'm not telling you, like I'm never going to say, write the domain and range using interval notation. I'm just going to say, tell me the domain of this graph. So if you forget the little curly brackets, I'll probably draw them on there, but I'm not going to mark you off for it. I just want you to know that it goes from -10 to 4, take a break, then only y equals 5. Okay. Good so far? All right, let's graph a different one. I have a new graph here. All right, I think this is on a new page. Flip over. We are almost done, you guys. We're going to do 2 more. They'll go fairly quickly. All right, I have 2. Are these both straight lines or one of them curved? They're both straight. So I only need 2 points to graph each segment. I'm going to pick the 2 points that are in your inequality. So for x plus 3, in your table, I want you to write x as -8 and x is 1. And you just need those 2 points. For the other line, what 2 points do you think you'll pick? 1 and 7. Now you can put them right underneath. Visually, like I need to break them up. Like I like to break them up for you guys. You don't have to skip a space, but I'm going to. So do 1 and 7. So let's evaluate. You can use your calculator, you can use your brain. If I put -8 into that first equation, what output do you get? -5. All right, what kind of dot is going to go there on your graph? A closed dot. All right, if I put 1 into that function, what output do you get? 4. And will that have an open or a closed dot? Open. Ooh. At 1, it's open because it's just less than.
I forget to say that.
Yeah, your brain said one thing, your mouth said another, huh? All right, if I put 1 into the second function, what do I get? 10 minus 2 times 1, 8. All right, what kind of dot's going to go there?
Close.
Close. There you go. And if I put 7 in, what output do you get? -4. Or however you said it. All right, and that'll also get a closed dot. All right, let's graph these. You only need 2 points, so you're just going to connect them. So I put a closed dot in -8, -5, which is down here, and an open dot at 1, 4. And then you can connect those. Doesn't have to be perfect. And then you're going to graph another segment, both with closed dots. One at 1/8, and at 7, -4. That's your new piecewise graph. Now, how many pieces does this graph have? 2. It has 2 segments. Again, we've talked about the reason because the domain for each piece has 2 endpoints. So there are 2 segments on this graph. Now, we haven't really talked about this yet, but why, if I'm going to have just an open dot here, right? Because 1 is not actually included in the domain for the first equation. Why do you think I still need to put it on my table and then put it on my graph? To visualize it, yeah. I need to put 1 on the graph 2 times. I need 2 dots there so that I can visualize where the graph is going. Right? If not, then I'm just kind of like, well, what's happening at 1? So yes, you do need to evaluate both endpoints, even if there's going to be an open dot. Okay? I'm not going to write that down because that's kind of a mouthful to write down. All right, we talked about including the endpoints. Oops, I went too far. I want to skip down here to the domain and the range. Okay, domain. Where are we on the left here? How far left do I go? -8. Okay. So I'm including -8. Now, do I ever have a break in my domain until I get to 7 over here? No. These dots fill in, so you're from -8 to 7. Now let's talk about the range this time. Where's your lowest y value? -5 with a square bracket. Now, I do have a jump here. See how there's a jump between the dots? But if I had that jump there, are there still y values being covered during that jump? Yeah, so I don't have to do the union this time. Where does my range go from? It goes from down here all the way up to 8 with a closed dot. So that was a little different because you start down at -5 and every y value is covered even though there's a gap in the grass. Sophia's looking at me with a funny look. Are you okay?
Yeah.
Are you sure?
Yeah.
Okay. We'll keep doing these. All right. Now this last one. How many equations are there? 3. How many pieces are going to be on your graph? 3. Now, let's talk about each one. X squared, is that a straight line or a parabola? A parabola. So if it's a parabola, how many points at a minimum do you have to put on your table? You need at least 3. So, notice here, there's only one endpoint on this graph. This is going to be a ray because there's only one endpoint. Right? You're in an arrow. So if I only have one endpoint, I have to be sure to include -2 on my table. But I have to pick at a minimum 2 other x values to plot so I can see the shape of the graph. So let's see. Why don't we just pick -3 and -4? I have to pick at least 3 of them. It doesn't matter. You can pick -10, but we'll just do -3, -4. All right. The next line is y equals 2. Is that a line or a parabola? A line. So how many points do I need for a line? 2. I'm going to use the 2 that are already on my domain. So I'm going to skip a space here. I'll do -2 and then 1. That'll be for the next graph. Then the last one, at y equals -2. Is that a parabola or a line? A line. So how many points do I need? I need 2. They only give me 1 point though. They give me a point at 1. I need a second one because it's a line. So what other point do you want to choose that's bigger than 1? 2. Okay. It doesn't matter to me. 2 is fine. But remember, you have to have 2 points for a line, 3 points for a parabola. Otherwise, you're just going to not know where to go. All right, so let's evaluate this. If I put -2 into x squared, what do I get? 4. -2 squared is 4. What's -3 squared?
9.
And -4 squared?
16.
16. All right, let's graph it. What kind of dot's going to go at -2? Open. So I'm going to put an open dot at -2, 4. And then I'm graphing just a piece of a parabola. So I'm going to plot the point -3, 9. And then -4, 16 doesn't fit. Okay, so you only have to connect these two, but make sure it's still going on. Remember, this is a ray. There was only one endpoint, so my graph just keeps going. So what you graphed was really part of this parabola, right? Don't draw this, but this is the parabola you were graphing, but you just graphed it from -2 over there. So you don't need to graph the rest of it, because it's not in the domain we need it. So let's do the next one. Y equals 2. That's the equation. What have to be the y values over here? 2. And let's talk about the endpoints. What kind of endpoint goes at -2, 2? A closed dot, so we'll plot that. -2, 2 gets a closed dot. What about at 1, 2? An open dot. So then we go to 1, 2 here with an open dot. Now we're on our last line. I have to do 2 points here to know where it goes. If I put 1 into that equation, what do you get? -2. If I put 2 in, what do I get? 4. What kind of dot goes at 1? It says greater than, so it'd get a open dot. So let's put an open dot at 1, -2. Now that's the only endpoint for this section, or for this section. So if I plot 2, -4, that just tells me where to go. That just says, oh, my graph is heading this way. I'm going to keep drawing an arrow. So you need the second point so you know what line to keep graphing. So that would be your piecewise function here. So let's finish with the domain and range, and then we'll be done with this for today. So let's see, my domain. If I start on the left, where am I heading towards? -infinity. All right, I go up to here. I have an open dot, but there's a closed dot there, so it's okay. I keep going on my axis, and I get to 1. At 1, is there a closed dot? No. Is there an x value of 1 anywhere on your graph? No. So what do I have to do with my domain? I go from negative infinity to just 1. Yep, just 1. I don't continue my domain because there's no closed dot here. There's no value for x equals 1 on my graph. So I get up to 1. But my graph keeps going. So what do you think I have to do? The union. Where does my domain pick up? Still at 1, right? There's an open dot from 1 to infinity. So your domain, really what that's telling you, if you want to think about it as set notation, is all the x's in the world, but not x equal 1. That's what the interval notation is saying. All the x's except 1. And this is probably the hardest part for today, is doing these domains and ranges. We will do this on pretty much every problem. So don't feel like you have to be perfect at it today. We'll get better at it as we go. All right, the range. Start on the bottom. Where are we going? Negative infinity up to negative 2, right? We just stop at negative 2. Then we have a break. So I'm going to go to negative 2, put a parenthesis. Now I have no y values until I get to 2. But there's nothing except for 2 there. So how did I do just one number? Union and the squiggly brackets, right? That was a really bad squiggly bracket, but that's okay. We'll pretend it looks pretty. I don't even know what that looks like. Oh well. Anyways, then I have a break from 2 until I get to 4. I start my range back up again. So there's negative infinity to negative 2. Then I have no y values until 2. And then my last set of the range goes from 4 all the way up the rest of the positives. That would be your range. Kaylin, what's confusing?
Where did the negative 2 come from?
This y value right here. So you go from negative infinity and then you stop at negative 2. And there's a break in y, so you get to positive 2. Alright, so on your paper, there's 2 questions on the back. I'd like you to try them. Remember, most importantly, a line you need 2 points, a curve you need 3. Alright, try your best. Keys on canvas. We will go over this before we start our little set of notes tomorrow. We have